Welcome to the channel where all you got to do is build your own Flowbench. Okay, so we're going to build a Flowbench. First of all, what is a Flowbench and why do we need it? So a Flowbench is basically a wind tunnel for components, cylinder heads, intake manifolds, air filters, intercoolers, whatever you need to flow. Um, you can rub on a intake port and looks bigger, looks shinier, may not flow better. So it's kind of like aerodynamics. What should work usually does, but sometimes it doesn't. So you have to check it. So why don't you just buy a flow bench? Well, they're pretty pricey. You can get a cheap one for used $5,000-6,000 maybe. A top of the line one costs you 15. Um, so I'm racing a junky old Lemons car, so can't really afford to purchase something that expensive for very little use. So why did I decide to build one? Besides those reasons, 25 years ago, I had an engineering company that did cylinder head work and engine development work and stuff like that. And we needed a flow bench for legitimate purposes for customers. And we tried to buy one. Um, we could give people our money, but they wouldn't give us a time when it would be delivered. So that didn't work for me. So how hard could it be? So I built one. And this was 25 years ago, so computers were around, but not super easy to manipulate. So data acquisition was quite expensive. So I did the old school way with manometers and YouTubes and orifices and stuff like that. And it worked fine. It was quite accurate, and it got the work done. So 25 years later, mass aerometers are quite a bit more available, easily accessible, cheap, and YouTube manometers have been replaced in the HVAC industry with electronic ones. So I decided instead of making a giant thing, I would make a kind of more modern, sits in the corner, doesn't take up as much room. So basically, in order to build a flow bench, you need 4 things. You need some sort of a blower or more, right? Superflow uses like 32 itty bitty little very low pressure blowers. They're all on when you turn the switch on, so it's not a great solution from a, well, let's put it this way: when you're trying to flow something with very low flow, like low lift valve flow or something like that, it's you have to be quick, right? You have to turn it on, get your number, turn it off, because all the blowers are going, and the only thing cooling the blowers is the air going through them. So these things pull 30 amps, 240 volts, 30 amps. So there's a lot of power, and that all goes into heat. And if you're only flowing 10 CFM, 20 CFM, 30 CFM, it's not enough to cool them. So you got to get in there fast if you do that. What I decided to do was stage them. So if you're doing low flow, you just turn one fan on. Turn medium flow, you could turn 2 on, yada, yada, yada. So you're going to need a blower. You're going to need a way to measure the airflow, whether it's a volume meter or a mass meter, doesn't matter. I decided to use a mass air meter because they're available and cheap. Also need some way to measure the delta P. So you can use a YouTube manometer for that, or you can use one of these HVAC electronic manometers, like 40 bucks. And then you need kind of a design, something to hold all the pieces together, to not leak, to take the forces. 28 inches of water doesn't seem like a lot of pressure, but it's like 1 psi, and you multiply that over a big area, the force it's not insignificant. So, and then you need some way to look at the data. You need a spreadsheet. Everybody's got a spreadsheet these days. So I just kind of stole the one that I had, and instead of using the math from the YouTube manometer and um, the Venturi flow meter, I just changed it to mass error stuff. So that was a pretty simple solution. So this is what the Flowbench looks like. Missing a few knobs and stuff, but in general, this is the general shape of it. This is 40 inches tall and 30 inches wide and 12 inches deep, approximately. Let's hide the front so you kind of see the giblets of it. These are my leaf blower motors. Toro, blah, blah, blah. I forget what it is, 340 CFM. I believe they pull about 12 amps each. So you run this on 240, you're going to need 25 amps. I think I have it on a 30 amp breaker. So it needs a lot of power, as most flow benches do. But the general operation of it is when you want to flow the intake, you put the cylinder head over this hole. When you want to flow the exhaust, you put the cylinder head over this hole. And what happens is you draw the air through here, through the mass air meter, goes through this blower, goes through this blower, goes through this blower, goes through this blower, and then out through this pressure chamber. In this case, it's not pressurized because you're flowing the intake, but this would be a pressure chamber flowing exhaust. This would be a vacuum chamber flowing the intake. And then the pressure between here and here is measured with the manometer. Whether it's a YouTube manometer or electronic manometer, doesn't matter. A couple idiosyncrasies with this. You can't just run air through the cylinder head directly into the mass air meter. You got to put a kind of a deflector in here to get it to kind of go around the deflector and through the mass air meter. Otherwise, the flow coming off the valve is super dirty, and it will mess up your mass air meter. The mass air meter is measuring a small percentage of the air going through it, and the only way it works is if it can multiply that by the amount of area ratio there is. So you got to get the air to go through there evenly. So you have to have a deflector there. The other thing that's not shown here is you need to put power in, and not only for all the four blowers, you got to get power in, 12 amps each at 110 volts, but you also have to have a power supply somewhere to power the mass air meter and to get the signal out of the mass air meter. So kind of this is an oversimplified schematic just to do the wood butchery. And the rest of it's kind of, you just wing it. Okay, so here's the completed flow bench. Makes a lot of noise. Lower throttle body here. So this is the final product. Got a couple of pieces of interest. These are the four lower motors. They're variable speed, but not infinitely variable like I was hoping. They're actually, there's like 5 steps of each of them. Or like 6 steps. So if you want more flow, you just turn more and more of them on or to a higher speed. This is the pressure transducer. So turn that guy on, push diff to set it to 0. And then this measures the pressure between this housing for this plenum and this plenum. So set that to 0 before you start. This is just a standard voltmeter. Put it on voltage. It's not turned on right now because the switch isn't on. Gotta make them out for that later. For some reason it shows 0.13 volts at 0, but that's essentially no flow anyway. So when you're flowing something, take this data sheet here and fill it in. Put your valve sizes, number of valves, seat width. All this junk is to kind of determine how well this is as opposed to a perfectly flowing cylinder head. So it plots some parameters I'll go into a little later. Valve seat angle, that gives you the curtain area increase. Stem diameter, that gives you the volume flow cross section. And then you put the temperature in here. Close is good enough. It's a mass air meter, so it's not that critical. And then you put, so this is an old, here's one that I've already flowed. So you put the volts and the port drop in there. And it's got a place so you can do two flows. If you want to compare one to the other, you can just cut and paste it. So this is we name all our cylinder heads, well actually all our engines on the Team Apathy as some sort of a horse. Don't know why, it's just what we do. So this is the Mustang head, which is just it's a B204 head actually. So this is the one that's in the car, essentially stock. But let me give you a little demonstration of how this thing works. So we can't see these very good, but so that's like 23, 24 inches of water, 4.8 volts. I flowed this yesterday and plugged it in the computer. That's around 400 CFM. So this thing will flow about 400 CFM at 24 inches. If you put a smaller restrictor here, it'll flow slightly less at a higher pressure. So this is probably a cylinder head that flows 320 CFM at 28 inches is probably capable of flowing it to max lift. A couple other pieces of information. I said earlier about you need to put a screen in there. So there's a screen in there so you can't drop anything. And I mentioned deflector. So there's the deflector. Mass air meter is right underneath that. Obviously the four knobs, and then this thing that's how I got the power out from the mass air meter. Just kind of set your voltmeter in there. And then this is to turn it on and off. It's not constantly working. And that's it. There's wheels on there so you can kind of move it around.